In this video, we're going to go through part 2 of the notes on 5.3.4, which is the quadratic formula. So in the note packet, it's on page 3, but you'll just need a notebook. So in part 2, we're going to take our quadratic formula knowledge and apply it to a real-world scenario, to a context. So in a context, we need to answer using units and address the question that's being asked. And so when we are given a problem, we want to figure out what is it asking, how can we possibly use the quadratic formula to help us solve it, and then once we get a numerical answer, how do we apply that to the context? How do we actually answer the question? So the first thing we need to talk about is typically problems will ask for one of these two things. They'll either ask for the y-intercept or the roots, or even both. And so the y-intercept we've talked about in first semester. It's just a little bit different with quadratics, but it's the same concept. The y-intercept is just the starting point. So if a problem's asking you for anything that involves the starting point, you are actually looking for the y-intercept. So you don't even need to use the quadratic formula for that. You just need to find the starting point, which I'll talk about in the first problem. But then if it's asking you for the roots, it's asking you for the x-intercepts, or they're also called the zeros. And this is where we would want to use the quadratic formula. And what these actually are really dependent on the scenario. So if you don't have this first part written down, please do that, and then we're going to go through an example. This example, you first want to read the problem just trying to figure out what's going on. So it says Juan's stock portfolio is represented by this quadratic function, where V, so what it is the value of the portfolio in hundreds of dollars, and T is the time in months. So it's saying like over a certain number of months, we can put in the number of months, calculate it, and that would give us the value of the portfolio. So after 1 month, you could plug in 1 and see where it's at. After 12 months, so a year, you could plug it in and see where the value is after that. So then it says, how much money did Juan invest initially? And then after how many months would the value be diminished to $0? So the first question it asks is, how much money did Juan invest initially? And anything with the word initially or starting or beginning should make you think of the y-intercept. And the y-intercept is very easy to find from the equation. It's just the constant involved. And so the constant is 50, so that is my y-intercept. And so to answer, I'm going to label this like question 1. To answer question 1, we can say Juan invested $50 initially. So he started with $50. So if it's ever asking you for the y-intercept or the starting point, it's always the one without a variable. So that's where we started. If there isn't one without a variable, then you started at 0. So then question 2 is the second one. After how many months would the value of the portfolio be diminished to 0? So this is saying, when would V be 0? And so what I'm going to start by doing is plugging in 0 for this V and seeing what I get. So I have 0 equals negative 3t squared plus 73t plus 50. And so this one is asking for the x-intercept. It's asking for when this value is 0. And so we're going to use the quadratic formula to solve. And so in this case, it worded it as like, when will this be 0? So you set your function equal to 0 and then you solve. Sometimes it's going to ask you like, where does the ball hit the ground? Like if we imagine off to the side, we throw a ball and it hits the ground, that is the x-intercept. So right here would be the x-intercept. And often these scenarios do have like some sort of projectile being thrown or launched. And so that's a very common one for the x-intercept. So once we know that this is set equal to 0, my only way to get t by itself, my only way to solve is to actually either factor it, which it doesn't look like I want to factor because this is not 1, or use the quadratic formula. So if we use the quadratic formula, my first step is to label a, b, and c. So my a is in front of the t squared, so -3. My b is in front of the t, 73. And my c is my constant, which is 50. And then I'm going to go ahead and plug those into the quadratic formula. So I know this one by heart. You guys will get this on your tests, so don't worry about memorizing it, but you do need to know how to plug everything into it. So I'm going to plug everything in kind of up here. X equals negative, and then my b is 73, plus or minus the square root. And then I have b, which is also 73, squared minus 4, and then a, and then c. So my a value is -3, my c value is 50. And then this is all over 2 times a, and a is -3 again. So we have these all plugged in. You want to make sure you use parentheses for every single one. And then remember, we want to start simplifying this in parts. So we do this first part, then this second part, and then this third part. So negative and 73 just give me -73. And then I want to type all of this into a calculator. So you can do this in the Google calculator. I have my own, so I'm going to use that. You want to hit the square root, and then I want to type everything exactly as I have it. So start a parentheses 73 squared. Remember on the Google calculator, it's the X to the Y button. Then I have -4 parentheses -3 parentheses 50. Did I accidentally do a negative in there? Oh no. Let me type that again really quick. I think I accidentally did a extra negative. There we go. Okay, so I get 77. Remember, if it's a decimal, you just want to round to 2 decimal places. I just accidentally typed a random negative in there. I didn't mean to. So ours is 77. Over 2 times -3 is -6. And once we simplify in parts, we want to split it into 2 problems. Remember, we want to split it into a plus problem and a minus problem. So I get -73 plus 77 and -73 minus 77. So for this first one, when I do plus, remember to hit equals after you do the numerator. We get -0.6, repeating. And then down here, I get 25. So those are my 2 answers using the quadratic formula. But when you are given a context, you have to interpret these answers. These are not your answers anymore. You have to use these to figure out what your answers are. So the question asked me, after how many months would the value of the portfolio be diminished to 0? So we need to look at our answers and we need to see if they both make sense or only one of them makes sense or none of them do. It's realistic that any of those could be the option. If the value is always bigger than 0, so he's always making money, then none of them would make sense. If it's always going to be negative or always going to be 0, then there might be 2 options. So you just want to make sure that they make sense. But this is asking after how many months. So I just look at each one and I say, does this make sense? So after negative 0.6 repeating months. I hope in your head you said this does not make sense because of that negative. We cannot go back in time. So this does not make sense based on the context. Now let's check the other one. This one says after 25 months, the value would be 0. Well, that does make sense. So this is our answer. So I'm just going to answer the question really quickly. My answer to number 2 is after 25 months, the value is 0. Or the value is 0 after 25 months. Doesn't really matter how you write it as long as you answer the question. So part 2, really the only difference, because we've already done the quadratic formula, the only difference is being able to address the actual problem. So can you solve the problem and answer the question using the quadratic formula, not just doing the quadratic formula on its own.